Hello everyone, welcome back to vishnusmart info channel. This is your track to physics mentor this side, charu sharma. In the last 4-part videos of mechanical properties of solids, we have completed the whole chapter successfully. So in this video, we are going to discuss some important points which could not be covered in those videos, and these points are very important regarding the exam, and they may be asked in the form of objective, or else some numericals also can be asked on these important points. So in this video we are going to discuss about 17 important points. Also, I could not explain strain energy in the last part 4 video, so that strain energy also I have covered in this video itself. Okay, so let's get started. Also, I am planning for something new coming on the channel, not on the channel actually. So that will help you, that plan will help you to bring up your consistency to solve numericals in physics or any other subject, chemistry or biology. Also, it will help you to increase your time lab, like how many questions you're doing in how much time. That also it will help. Also, it will help you to build up the confidence and faith in your preparation. And the most important thing, the consistency and time management. These two things I am focusing on. So the plan will be in few days on the channel. I will announce it, but due to some work I am busy nowadays, so I could not get the plan on the channel. So by December it will be on the channel. Also, if you want to be the part of that plan, then what you need to do is you need to like and comment on each and every video of the channel. Then only we will come to know, okay, this is the person who is interested. So like that. And also, especially on the comments, you need to put whatever you are liking in the video, or whatever you did not dislike this video, like what was the quality which you didn't like in the video, what was the problem you faced, or what things you do not understand. So whatever are your problems and whatever are your suggestions, anything you can mention in the comment box below. Okay, and also share it to your friends. So liking and commenting on the video is a must to be the part of that plan. Okay, so let's start with today's class. So in today's class, instead of like how I will be teaching is on the paper board, right? So I'll be taking the marker and explaining each and every points. But here I said these are the 17 important points, and some points are related to each other. So what did I plan to make? Note it down on a paper, and then I will be explaining them. Okay, so the important points to remember in mechanical properties of solids in this chapter. The first point already explained that strain has no units. What is strain? Strain is change in length. Strain is change in length upon original length. So the change in length upon original length. The change in length is also calculated in terms of length, like meter, and divided by the original length, and this length is also calculated in meters. So meter and meter gets cancelled, hence it will have no units or no dimensions. Okay, both the quantities are same. Next, coming to the second important point, that is in Hooke's law graph, I have discussed about plastic region. If you have any doubt or you don't know about Hooke's law graph, you need to go to the playlist of mechanical properties of solids on vishnusmart info channel. In that playlist of mechanical properties of solids, part 2 video, part 2 lecture 2, I have explained completely on Hooke's law. That whole video is dedicated on Hooke's law only. So from there you need to learn what is Hooke's law and what are the plastic regions, elastic region, elastic behavior, plastic behavior. All these terms you need to understand. So regarding that video, I have already mentioned in that video, but this is very important objective point which they ask is in Hooke's law graph, if the plastic region, if you see small, then which type of the material it is? It is a brittle type of material. And if the plastic region is large, then the material is ductile. Now what do you mean by plastic region? Means the body will have plastic nature in it. For example, I have explained in that video yield point and fracture point. So that regions you should locate, that which region is called plastic region, which region is called elastic region. So if you, in that graph, if you find the distance of plastic region to be very small, the distance of the plastic region is very small, it means the material is brittle. Brittle means what? It will break easily. If you increase the stress little bit more, the body will break off. So once the body gets break, we can call it as brittle material. Means plastic region is very small for it. Similarly, if the plastic region was very large, it means the body is ductile. Means how much ever stress you are applying, it is still getting stressed instead of getting breaking. So it's not getting break off, or it's not getting any cuts from between. It's still long and nice stretch is there in the material. Then that material you can call it as ductile. So if plastic region is large, the material is ductile. Now coming to the third point, that is elastic hysteresis. So this is a separate concept. Something hysteresis means regarding the loss, regarding the energy loss. So here elastic hysteresis means what we will see, the body will show its elasticity. How if we apply stress, the body will have some strain produced in the body, and if we decrease the stress, the strain will also decrease. So in this act of increasing the stress and decreasing the strain, all these things, what will happen, there will be some energy loss, okay, in the form of heat. So that all things can be calculated through hysteresis loop. So for elastic hysteresis, you can say it is a natural consequence. Why it is natural consequence? Because automatically when the stress is increased, the strain is produced. When the strain is decreased, when the stress is decreased, strain is decreased. So like that, whatever is happening, like when you are increasing the stress, strain is also increasing, right? And when you are decreasing the stress, strain is also decreasing, but there is some amount of heat generated, or I can say heat loss in the form of heat energy. So from that, it is a natural consequence of this process. You are increasing the strain and you are increasing the stress, strain is produced. So for all this is a natural process in the form of heat energy. Also, it is also after effect. After you do all these activities, stress increasing, strain decreasing, all these activities are done, then only you can see elastic hysteresis. Just a material is placed, you won't see any elastic hysteresis in it. Next, what do you by definition mean by it? Means it is the lag of strain behind the stress when body is unloaded is called elastic hysteresis. It is the lag of strain. See, for example, if this is my stress and strain graph, what will be the normal path for it? Like if you increase the stress, strain is increasing like that. This will be the normal graph, like this graph you got. Okay. Now what I am doing, for example, at this particular point, this is the amount of stress. Now what I did is, I decreased the level of stress. So as soon as I decrease the level of stress, according to my assumption, the graph should follow the same original path how it reached that particular point. But it will not do so. What will happen? Though you are decreasing the stress, the strain amount is still remaining the same. Means at this particular point, the amount of strain was this much. Now if you have decreased the stress also, still at this particular point, the strain amount is still that much only. It did not change. That means it is a lag of strain. Though stress was decreased, the strain is still lagging to come at its original position. It will take still more time to come at its original position. So from the original case to coming back case, you will get some loop, like this loop in the graph. That area of that loop will give you the amount of energy loss or absorbed in the form of heat. Okay, so this is known as elastic hysteresis. So hence the amount of energy which is absorbed. So whatever you came to know about elastic hysteresis, the loop, regarding this loop, the amount of energy is absorbed by the material in the cycle which appears as heat. So in this cycle, whatever you see, the area will let us know that how much energy was absorbed per unit volume. So the energy per unit volume is directly proportional to the area. For example, if I give you a question, this is one graph, this is one graph. Now I ask you, in which graph the area upon energy upon unit volume is more? In a hysteresis loss is more, like that question is asked, graph A or graph B. Then what should be your answer? Please do comment in the below. Means, what did I explain you? That energy per unit volume or energy loss per unit volume is directly proportional to area of the loop. Okay, so this is the concept of elastic hysteresis. Like this questions only will be there. So now my question is, you have graph A and graph B. This is the graph look like of A and this is the graph look like of B. Now among the both graphs, which is having more energy loss? You should tell me in the comment box below. Now coming to the factors. This elastic hysteresis has some important 4 factors affecting this, and also not only for elastic hysteresis, for other elastic properties also. The first factor is temperature. So once you increase the temperature, Young's modulus will decrease. That means elasticity will decrease. Only the exception is elasticity of invar. For invar, if you increase the temperature, you decrease the temperature, nothing will happen. Elasticity and Young's modulus will remain the same. Next, coming to impurities. The elastic nature of a material will depend upon the impurities you are taking. Okay, depends upon the type of impurity. If you are taking a impurity which is elastic, then probably it will also increase the elastic nature of the material. But if you are taking a impurity which is also brittle in nature, it is not elastic, then the material with which you are adding, that will also not increase its elasticity. For example, iron. For iron, if I am adding carbon, the Young's modulus will increase, elasticity also will increase. For gold, if I am adding potassium, then Young's modulus will also increase, elasticity will also increase. So here, for iron, carbon is added, for gold, potassium is added to increase their elasticity, means to make their elastic nature more strengthened. Next, coming to annealing. What do you mean by annealing? Annealing is nothing but a process of regular heating and cooling. So regular heating, cooling, like that continuous process is followed, and you will get a large grains of the crystals. Like for example, steel is there and you are doing process of annealing for steel. That means large amount of large crystal size steel you will get, which will the process of annealing, which will lead to elasticity decreasing. Means by the process of annealing, your elastic nature will decrease. Similarly, there is called hammering and rolling. Hammering and rolling, by the word itself, it means making them into small pieces by hammering and rolling. So by hammering and rolling, the elastic nature of the body will increase. Okay. If you have any possible suggestions why for annealing elastic nature will decrease, and why for hammering and rolling elastic nature will increase, if you have any reasons, please let me down in the comment box below. Okay. Next, fifth option. Fifth important point which I want to discuss is Young's modulus for perfectly rigid body is infinity. Young's modulus for perfectly rigid body is infinity. Why? See, Young's modulus means what? Stress upon strain. Now, perfectly rigid means how much ever stress you apply, the strain will be 0 only. And once numerator by denominator is 0, then automatically the whole term becomes infinity. So, Young's modulus for a perfectly rigid body is infinity. Next, the sixth point is breaking stress does not depend upon the cross section of the wire or area. For example, this is your wire. Okay. For this wire, the amount, suppose at some particular level, at particular stress, this wire will break. So that stress at which this wire is breaking is called breaking stress. But your breaking stress, won't be like how you write stress. Stress is equals to force upon area. So from this formula, though, we will think that stress is inversely proportional to area. But for breaking stress, there is no relation between stress and area. It will all depend upon the weight or force you are applying. Okay. And also on the type of the material of the body. Next, coming to another graph, a strain and stress graph. Actually, I thought to put this one as a question, but now I am explaining it. See, Suppose this is your graph stress, normal general graph, stress and strain graph. So you know that the slope of this graph, what? Slope of this graph will give you Young's modulus. Okay? Slope of this graph will give you Young's modulus. And here I explained you that y is inversely proportional to temperature. Y decreases, temperature increases. Temperature increases, y decreases. So there is a relation of inversely proportionality between temperature and Young's modulus. So I am giving you a hint that y is inversely proportional to temperature. First hint. Second hint, slope of stress and strain graph. Remember slope of stress and strain graph. Here I have given a graph of strain and stress. Here the graph is stress and strain. Remember. So slope of stress and strain graph. Slope of stress and strain graph. Slope of stress and strain graph is y. Is giving you Young's modulus. So here the slope, this slope is Young's modulus. Now here what I have done, I have changed, first of all I have made y-axis strain, stress. So now here I have written a statement that T1 temperature is greater than T2. Okay. I have written a statement for this graph that T1 temperature. So I have, see now one example I will give. For example, A material and B material. From A and B I can say that slope of A is greater than B. So slope of A is greater than slope of B. For this graph I am talking first. Okay. Slope of A is greater than slope of B. Also I told you that slope will give you Young's modulus, means I can say that Young's modulus of A is greater than Young's modulus of B. I can also say this, right? But I have also explained you that Young's modulus is inversely proportional to temperature. Young's modulus is inversely proportional to temperature, means YA is greater than YB. Similarly, I say that A material is kept on temperature TA and material B is kept on temperature TV. So as Young's modulus of A is greater, temperature of A will be less because they are inversely proportional, and Young's modulus of B is more, means temperature is, Young's modulus B is less, means temperature is more. So from this graph you can say that B is at a higher temperature, A is at a lower temperature, right? So how you got that? Stress and strain graph, say you found first slope, then slope you found how it is related to Young's modulus, that slope of stress and strain graphs will give you Young's modulus. Slope of strain and stress graph will give you 1 by y, not directly y. Okay. And you also know that y is inversely proportional to temperature. So all this concept you need to apply for this question, that I have given you strain and stress graph, and I have given you T1 points, T2 points, and I have given you directly a statement that T1 is greater than T2. Now you need to let me know in the comment box below that this 7th question statement T1 is greater than T2 means this T1 temperature is more than T2 temperature. Whatever the material was at T1, its temperature is more than the material which was at temperature T2 here. Okay, you need to know that it is correct or not. This statement what I have given is correct or not. This is the question. Okay, this is the question, and already the concept I have explained how you should get it. The twist what I did was I am already telling you the twist also. This is stress, this is strain. Here I have kept strain, here I have kept stress. So for here slope you should take 1 by y. Next, 8th important point, substances which can be elastically stretched to a larger value are called elastomers. So the substances which can be elastically stretched to a large value, large amount of strain, are called elastomers. This is very important, clear by statement only. More stress you produce, more strain you can see, they are more elastic, elastomers. Next, Young's modulus of elasticity for a gas is 0, obviously, because liquids and gases don't have Young's modulus. Okay. Next, move on to the further statements talking about bulk modulus. So bulk modulus I already explained, normal stress upon volume strain. Related to volume it will be, so stress is similar like pressure, so I write change in pressure divided by volume strain means change in volume divided by original volume. Okay, volume strain, change in volume divided by strain means what? Change by original. So change by volume, change in volume divided by original volume. Stress is like pressure only. And I have kept a negative sign here. Why I have kept a negative sign here, because that pressure and volume are inversely related by Boyle's law. So if pressure increases, volume will decrease, and volume increases, pressure will decrease. So inversely related, so here that comes a minus sign. But although the whole B value will get a positive quantity only, don't worry. Okay. Now bulk modulus will be there for solids, liquids and gases. And also bulk modulus of solids is greater than liquids, is greater than gases. So these are the important points relating the bulk modulus. Now there is an important relation between density, pressure and bulk modulus. That is, change in density is equals to original density into change in pressure divided by bulk modulus. So D is density, change in density. This D is original density. Delta P is change in pressure and B is the bulk modulus. So how do you get this relation? Is instead of volume I kept density. Why? Because you will get this equation by substituting here density is equals to mass by volume. So instead of volume you can substitute m by d, mass upon density, and you know that mass will remain constant, it will not change, only volume and density will change. So you can just according this relation substitute in this formula, you will get this formula. So instead of substituting and remembering, you can directly remember like this. Okay. Next, 12th important point, perfectly rigid body, bulk modulus will be infinity. I already told you, rigid body means what? Strain will be 0. Strain రావద్దు, strain అందులో లేదు. Strain లేదు అన్నమాట అంటే కింద డినామినేటర్ 0 ఉంటుంది. డినామినేటర్ 0 ఉంటే మొత్తం వాల్యూ మీకు ఇన్ఫినిటీ లాగా వస్తుంది. నెక్స్ట్, గ్యాసెస్కి ఏం మాడ్యులస్ ఉంటాయి, సాలిడ్స్కి ఏం మాడ్యులస్ ఉంటాయి అంటే సాలిడ్స్కి యంగ్స్ మాడ్యులస్ ఉంటుంది, బల్క్ మాడ్యులస్ ఉంటుంది, రెజిడిటీ మాడ్యులస్ ఉంటుంది. లిక్విడ్స్కి అయితే పుట్టి బల్క్ మాడ్యులస్ ఉంటుంది, గ్యాసెస్ కూడా బల్క్ మాడ్యులసే ఉంటుంది. యంగ్స్ మాడ్యులస్ ఇంకా రెజిడిటీ మాడ్యులస్ ఉండదు. ప్లీజ్ ఇగ్నోర్ దట్ సౌండ్. నెక్స్ట్ 14th point is isothermal, adiabatic, isobaric, isochoric. For this, how do you represent your bulk modulus? Because these as I said you that gases can be expressed through bulk modulus. Now for gases it will compress, it will expand at constant temperature, constant volume, all that things will be there na, constant temperature, constant volume, constant pressure. Okay, no heat energy absorb or loss. So like that statements will be given. So from that we should decode that is it a isothermal process, adiabatic process, isobaric or isochoric. Isothermal, from the statement only, iso means same, thermal means temperature. So at same temperature, constant temperature, gas is expanding or compressing. What is the bulk modulus? It is equal to the pressure of the temperature. Suppose if they say that there is no heat energy loss or absorbed. No heat energy lost or absorbed means it is adiabatic process. It is adiabatic process. For adiabatic process, bulk modulus will be equal to gamma into pressure. So what is this gamma value? This is nothing but Cp by Cv. Next, isobaric and isochoric. Pressures you will measure in bar, right? So isobaric means at constant pressure. If pressure is constant, then bulk modulus is 0. Why? Pressure is constant means delta P is only itself 0. So numerator is 0 means whole answer is 0. So bulk modulus is equal to 0, not infinity, this is 0. Okay. Next, coming to isochoric. Choric means volume. So constant volume, if they say constant volume means C, delta V by del V naught will be 0. Denominator is 0, whole terms turns to be infinity. Okay. Next, so this we have discussed till here. Now comes your strain energy concept. So for strain energy, nothing more they will ask you. What is strain energy? For example, this is your wire. You are stretching this wire by applying a force F and some delta L elongation is produced. So some delta L elongation is produced in this wire. So now what will happen? As you are applying force and elongation is produced means some work is done. Some work is done. Now that work done will be in two types. One, whatever you are doing work done, it will be divided into two parts in the internal system. One will be doing against the restoring force, whatever the restoring force, half will go against that and half will be in the heat production. So whatever is going in the restoring force, that will be stored as elastic potential energy. Okay, restoring force. So this will be stored as elastic potential energy. This is lost as heat in the surrounding. This will be stored as elastic potential energy. So this elastic potential energy is nothing but your strain energy. That's it. Easy. That's how easy it is. Okay. So let's come to that concept. So suppose wire is stretched and delta extension is produced. So they will ask work done first. Work done is nothing but force into displacement. Displacement is by delta L, extension is produced. So force whatever you applied into delta L. Please ignore that cracker sound. I can't help it. Next, work done against restoring force. I said you this F delta L will be divided into two parts. One will be restoring force and one will be heat. So half into F delta L, and for heat produced it will be half delta F delta L. Half of it. Half here, half here. Next, coming to elastic potential energy, this is only stored as elastic potential energy. And what is energy density? The energy density is nothing but energy upon unit volume. So this is your energy, half F delta L. This is your energy upon unit volume. Volume you will apply. So volume you can write as A into L, right? A into L. So you can see this part is your stress and this part is your strain. So you can write that energy density is equals to half into stress into strain. Okay. Also you can change this formula in different terms by using Y is equals to stress upon strain. By using this you can change this formula. For example, they are asking in terms of Y and strain. So put stress in terms of these. So half into stress, how you will put Y into strain, right? So Y into strain square. Similarly, if they are asking in the terms of strain, stress, they are asking to remove strain, then Y stress you keep like that only, and in place of strain you can write stress upon Y. So like that you can interchange the formula. So we are done with this much part. Now last two important concepts, 16th and 17th point. So depression, there is important, there is no derivation for this formula, just very typical cases they will ask, like very rare case this question can be asked, like one between two fixed supports, your wire is there and it's like pulled like this you have pulled it, so it will show some depression like this. Now what is the amount of this depression? So this depression is equals to mg into length ka cube divided by 4y bd. Okay, so in this formula they may ask you what are, means in this directly they may ask you to solve, or values will be given like m is the mass, g is gravity, l is the length of the wire, fourth number, then y is Young's modulus, b is the breadth, and d is the depth. Okay, so for length and depth cube will be there. So like that this formula is there for depression, very rare cases. Last topic, Poisson's ratio. So whenever they will tell this Poisson's ratio topic, assume the chapter is completed. So we are done successfully with the chapter. So Poisson's ratio is nothing but the ratio of longitudinal strain upon lateral strain. See, for example, this is your wire. So for example, this is your wire. If I am stretching this from both the sides, what will happen? I am stretching this from both the sides, means first thing will, its length will increase. Length will increase, right? If length is increasing, means longitudinal strain can be seen. If length is increased, what you will think? Diameter should decrease, no? Like if suppose this much mota the wire is initially, now you have stretched it, means you will see, no, that from this thing the diameter has decreased, right? Like this it has become very narrow, the wideness is decreased because you have stretched it like this. Can you imagine if I am applying a force like this F here, like this force F here, so this mota wire will become patla wire. Okay, and it length will increase. Like for example, your mummy will make rotis, so what she will do, like this, she will pull the atta from the whole flour, that whole atta, whatever the, what I say, the round big shape will be there. From that, if she's pulling one and she's making into a roll, and then she's stretching that, for stretching you will see that diameter of that will decrease and the length will increase for stretching part, like that only. So it is nothing but longitudinal strain upon lateral strain. For longitudinal strain, see, change in length upon original length. So change in length upon original length. Sorry guys, one small information, I really didn't notice that I wrote here ulta. I wrote the formula correctly, I wrote this thing ulta. I didn't notice also. That's why I was thinking, why is it so? Lateral strain upon longitudinal strain. Okay, so lateral strain upon longitudinal strain, and there will be a negative symbol, remember. So lateral strain upon longitudinal strain. So laterally means this is the lateral side. So for laterally it will be delta R upon R divided by longitudinal means change in length upon original length, and negative sign. So this is your Poisson's ratio. So for Poisson's ratio, he said theoretically the values of this ratio can be for materials from -1 ranging to 0.5, and practically the values are noticed greater than 0 only, not up till -1 values are not noticed, and less than 0.5. And if in the question they mention density is constant for that material, then directly go for the Poisson's ratio 0.5 if they mention density is constant. Okay, so we are done with the lecture. Now I wanted to discuss one important thing, that see, nowadays I'm getting little bit busy with some work, so I'm not able to continuously upload the video. So whenever the video is coming, compulsory at least 3 to 4 videos are there. 3 to 4 days, or I say videos per week is there, per week, so that you are not on a loss. Plus what I am doing is I am posting notes on Telegram at end of the chapter. At the end of chapter. Plus I am posting sums, I say problems in Telegram. So at particular I'm doing these 3, and I want you all to comment. Why I want you all to comment, you know, because once you comment your queries, suggestions, feedbacks, I can come to a conclusion that whether you are liking the sessions or not, and that conclusions will help me to bring up more efficient way. Okay, so for that, first you need to do is comment that yes, we like, or you don't. At least put some answers, whatever the questions I'm asking in between, put that answers. I am also on the live chat. You can ask me queries. Okay, so please do this thing and help, support. How can you support? You can support by like and comment and share. And you can see we are near to 100k. So reach us 100k soon. Thank you. Bye. Signing off here. Charu Sharma. Bye. Take care all of you.